everyone. Welcome to Fluxray Electronics. In today's video, we are solving all vector questions. Okay. So before going to actual solving, I want to tell that like whatever we are solving here or like what we previously saw, all that solution I upload here in my blog post, so you can check it if you want to. If you want to that code, so you can check out here in solution. I just upload all that thing. So if you want to like, I just distinguish like all things. So whatever the solution you require, you just in the front of there like view code option. So in Verilog language, what we are like now covering. If you want to check out the solution, so here like whatever the basic question and whatever the vector question. So I want to like check the vector question. I will go here and check out the vector questions. So whatever the questions are there, so you can like first question like, so the code is like here available. So you can see here. Okay. So let's go our actual solving. Okay. So this is like vector questions. So I previously solved all that question, but I forget to start recording. So let's start it. So first question is vector zero. So the question is, what is the question? Okay. Build a circuit that has 3-bit input and the output the same vector and also split into the separate 1-bit output. So we have like 3-bit of input vector, then we have like again 3-bit output vector. So this vector is, as it is driving, then again we have like three separate or like individual output bits. So the MSB is going to O2. Then next bit is like O1 is getting in O1 and the LSB is getting into O0. So let's solve the question. So yeah, let's go. So we have to like first assigning out v equal to what is our input vector vec. Okay. So I'm writing assign out v equals to our input vector vec. Okay. So after that we have to split these vectors. So MSB is going to O2. In that way, we have to store. So I have to write 3 times. So instead of writing 3 times, I'm pressing that Alt and drag. So assign my output vector name is like initialize with O, and the 210 are like not common in like everyone. So I'm just put some space and I will just write it like later. So O, and then whatever that I have to like put input vec. I have to assign the specific bit. So I'm using square bracket and not put any value for now. I will put individually value. So whatever my O is the same value I have here. Okay. So O2 is assigned to FEC2. So MSB is assigned to MSB. Then O1 is assigned to FEC1 and O0 is assigned by FEC0. Okay. So that's the solution for this question. Let's submit and check it's working or not. It's compiling. Okay, we get the status success. So let's jump on the next question. So this is our next question. Let's solve it. So they are like giving some different things, declaring vector, implicit nets, unpack versus pack array. This is like important things if you go into system Verilog. So accessing vector from the element, this is like an also important topic. So you are like using all that topics when you are like going to RTL designing or like a verification engineer. This is like important parts. So let's go to our question. The question is like a build a combinational circuit that splits an input half word. Half word means like half part of that. So the 16 bits. Okay, we have to there is like 16 bits are there. We have to split them into two 8 bits output. Well, let's go to solving the question. So we have like two vectors out HI we have to store MSB bits and out LO we have to store LSB bits. Yeah. Okay, let's go and solve this question. So assign. So first we are writing for MSB. So out underscore HI equals to in that upper bits we require. So in square bracket 15 down to 8. Okay. So we are using concatenation operation here. Okay, not required concatenation. We require to concatenation here. So instead of writing here, we are just writing in here and out HR, comma, out underscore hello. Okay. So this is one method and just discuss like next method also, like another method also. Just check out it's working or not. So submit and check it. In this concatenation method, we are like putting MSB first, then LSB second, and whatever the source we have to put as it is. So yeah, we get status success. So using concatenation operator, we are solving this question. So another method is like directly mapping of that vector. So by using mapping of vector, I'm solving this again. So first, what we have to store out HR. So assign out underscore HR equals to in. So out HR is like we know the 8-bit number. So, but we don't know like which 8 bits we have to store off in. So we are in square bracket writing the which 8 bits we have to store. So we have to store like 15 down to 8. So 15 down to 8. As they mention here in the question. So 16 bits is here. So first 8 bit we have to store in uh, out HR. So first 8 bit is like 15 down to 8. Just press the semicolon. Then next assign out underscore allow equals to in. So here we have to put 7 down to 0. So LSB bits. Okay. So this is the vector mapping method. So by using vector mapping method, we are like checking our solution is right or wrong. Just press the submit button and check it. It's compiling. Yeah, we get the status success. So let's jump on to our next question, vector 2. So our next question is a 32 vector can be viewed as a containing a 4 bytes. Okay, bits 31 down to 24, 23 down to. Okay, building a circuit reverse by byte ordering the 8 byte word A, B, B, C. Okay, so okay, just okay. So we have that question is that we have like for 8 bytes of word. Okay. So these are first 8 bytes, then second 8 bytes of B, then third 8 bytes of C, and last uh, 8 byte of D. Okay, so we have to reverse the order of the bytes. But by when we reversing, we don't reversing the index. So as it is the byte we are reversing. So this byte completely as it is coming as the first. Then this C byte is coming. Here is like second last. So here it comes second. So it's second here. So it's here comes second last. And here it's first. So it's going to last. Okay. Let's solve the question. So by concatenation, it's also possible and normal also possible. So first we are going with the concatenations. So the use of concatenation is only that we can reduce our code size. It's easy to read. So assign. So in concatenation, we are like putting output as it is. So assign out. So after that, we have to put input. So in concatenation sign we are putting. So first, what we have to put 31 down to 24 is the like first 8 byte is going to the last. So last going coming to first. Okay. So in we are like assigning. So in that way, so first we have to write 0 down to 7. Okay. Not 0 down to 7, but if we write 0 down to 7, so what happen? So this D is assigning here. So this D is coming to here. So instead of 0 down to 7, we are writing 7 down to 0 first. Okay. So in square bracket, 7 down to 0. Okay. After that, what we are writing? In 15 down to 8. Okay. After next bits are 23 down to 16. Okay. After that, the last byte is in uh, 31 down to 24. Okay. So by concatenation, you can solve this thing in single line. So let's run and check it it's working or not. The only thing you have to need thinking that first you have to write MSB always, then LSB because you have to follow the same whatever the pattern is here. So capital A is first, then A small a. So similarly here capital A first, then similarly A. So you have to follow this pattern. So that's why we are writing 7 down to 0. If the sequence is small a is first, here small a and the capital A is last. So we are writing 0 down to 7, 8 down to 15 in that way. Okay. So let's submit and check it. It's working or not. Okay. It's compiling. Yeah, we get status success. So another normal mapping way I am also solving here. Okay, if you don't want to implement the mapping method, so you can skip it. You can move the next question. So assign. So out here we have to put completely. We have to like map one by one byte. So first, whatever the 31 down to 24, we are mapping here with in 7 down to 0. Okay. Then assign again output of 23 down to 16. We are mapping with in 15 down to 8. Okay. After that, again assign. out. Here we have to 15 down to 8 in off. Here we have to put 31 down to 16. Okay. And last assign out 7 down to 0 equals to in off. Okay, here one mistake. Not 61 down to 31, 61 down, 23 down to 16. Okay, here 31 down to 24. Okay, so let's submit and check it's working or not. Okay, it's compiling. Yeah, we get status success. So let's jump on next question. So vector gates is the next question. So this is our next question, vector gates. Okay, so the question is, uh, we have to perform the following bitwise or bitwise, okay, bitwise and logical OR circuit. Okay, so this is our circuit. We have to perform this thing. Okay, so this is first we have to put out bitwise OR we have to put, then logical OR we have to put, and not. Okay, so let's go and solve the question. So assign, first we have to put bitwise OR. So assign bitwise OR. So A or B. Okay. Then after that we have to put logical OR. So in logical OR we are using double vertical lines. So out underscore or underscore logical. Okay. So A double vertical lines and B. So this is OR sign, like OR operator, logical OR operator. This is normal bitwise OR operator. Okay. So after that we have to put NOT gate. Okay. We have to concat the NOT operation of both A and B. Okay. So this circuit is like not okay. This A is going next and first A. Okay. So first bit are like MSB side is like B, not of B, and LSB not of A. Okay. So assign. Okay, okay, we are using concatenation here for mixing the both things. Okay. First we have to put not of A. So not of A. Okay. So first we have to put B. Okay. So B is first coming here. See here the direction. B is first coming, so negation of B, comma, negation of A. Okay, so it's bitwise not it's performed and it's concat to out not. Okay, let's submit and check it's working or not. Okay, yeah, we get the status success. Okay, let's move to next question. Okay, gates 4 is the next question. So the question is a build a combinational circuit with a 4 inputs, 3 down to 0. Okay, so we have one vector. Okay, in 3 down to 0. Okay, these three out. Okay, we have like three outputs: out and out or and out XOR. So out and is like output of four input and gate. Out or is the output of four input or gate, and out XOR is the output of four input XOR gate. Okay, so we have that in vector. Okay, which is like 4-bit size. Okay, we have to. So this is like 4-bit now. So whatever the in of three is and in this operation in of three is and with in of two, then in of two, what is the result of that in of three and in of two? And operation is doing and operation with in of one. So what is the result of that coming is doing and operation with in of zero. So whatever the final answer it's storing in out and okay in that way OR and XOR operation is performed. Okay, so let's solve it. So assign out of out underscore and okay. So we have to perform the AND operation of each bit of in. Okay. So first we are writing in of three and in of two, then again and in of one, again and in of zero. Okay. So similarly we have to perform here we have to perform AND operation. In next we have to perform OR operation and next we have to perform XOR operation. I'm not writing again this same thing. I'm just copy paste two more times. Okay. So the just change in name. So here instead of and we require to put or. So or okay. And here we have to perform XOR. So here XOR. Here one more XOR. And here one more XOR. Okay. So this is solution for this question. We'll just submit and check it's working or not. Yeah, we get status success. Okay. Let's jump on the next question. Okay. The question is okay. Here is the question. Given a several input vector, concatenated them together, then split them up into a several output vector. There are six pi input vector A, B, C, D, E, and F. Okay, for a total 30 bits of input. Then there are four 8-bit output vector W, X, Y, and Z for 32-bit output. Then output should be concatenation of the input vector followed by two one. Okay, followed by two one bits. Okay, so yeah, so this is our input A, B, C, D, E, F, and two high bits. Okay, we have to store this thing in W, X, Y, Z. Okay, using concatenation operator, we are solving this thing. Okay, sign. So whatever the output we have to put here, W, X, Y, Z. So I'm just copying all that thing. So here we are putting one concatenation sign. Okay, then if one assign sign we have to put. Okay, after that we have to put inputs. Okay, so first we required W, X, Y, Z. We required A, B, C, D, E, F, and 1, 1. Okay, so A is our MSB side. So just putting here. Okay, after that we have to put two 1 bits. Okay, so comma, two tick, binary, 1, 1. Okay, so this is the solution for this question. Just submit and check it's working or not. So before that we have to, okay, let me check. Okay, no, that's it. Just submit. Yeah, we get status success. One more thing before going to that. So this is not actually allowed in RTL design. Okay, whatever we are doing only for the solving questions. But in actual RTL design, we never, what you say that we never fix any value which we are assigning to output to any fixed or hard coded value. So here, 1, 1 is like hard coded value. So we are not fixing it because when we are like putting this thing in verification, so at that time we have to check in functional verification, we have to check that all things are toggling or not. So that's why this is actually for the RTL design, it's illegal. But for the sake of time, we are solving this question, so it's okay. Okay. Let's jump on the next question. The next question, vector R. Okay, vector R. So we have to reversal vector question. So in this question, what we have to do? Given 8 bit input vector is 7 down to 0. Reverse its bit ordering. Okay. So what we have to do? The whatever the 7 bit is going to 0th bit, 8 bit, 6 bit is going to first bit, then fifth bit is going to second bit. In that way, we have to perform. Okay. So using concatenation, we are doing. Okay. So if you go into system Verilog, in this there are like method possible. Reverse method we are calling. So you can directly reverse that things, but here in Verilog we don't have any method. So we have to like do it manually. So first assign, then out. Okay. So we have to put us out, then assign operator. So we have to concat all the bits. Okay. So 0th bit is going to 7th bit. Okay. So in concatenation we have like put MSB first. So out of 0 is going to first, then comma. Okay. I'm not writing all that things. I'm just changing the number. Okay. This is like short tricks which you require, like actually programming. In GVM, it's like much more easy if you using that uh, record command. So I'm just writing 1, 2, 3, 4, 5, 6, 7, one more 8. Okay. So first 0, then after that we have to put 1, after that 2, after that 3, after that 4, after that 5, after that 6. Okay. One more we require. So 7. Okay. So we are just reverse. So here the whatever the 0th bit it's assigned by out 7. Then 6 first bit is assigned by out 6. Second bit is assigned by out 5. Then third bit is assigned by out 4. In that way it's going on. Just submit and check it's working or not. Okay, some issue is there in okay. So I got like all output as zero, but in reference we get 0, 80, 40. Okay, some issues are there. So let's check out 0, 1, 2, 3. Okay, we are just mistakenly put that out here. So we have to change in. Okay, and that's the issue with the copy plus. If you copy one thing and that thing is wrong, so it's completely what we call double. You have to solve like write all that code for that. Okay, just fixing it. Okay, one that extra comma is also there. Okay, so just submit and check it's working or not. Now, error is occurring when you solving, so it's better to like get errors because if we get errors, so it's easy to debug when you are actually placing companies. Okay, so here we get status success. Okay, so let's go to our next question. So here is the replication operator question. Okay, the question is a build a circuit that sign extends an 8-bit number of 32 bits. Okay, this requires a concatenation of 24 copies of the sign bit, that is the replication bit of 7 times of, okay, 7 bit 24 times, then followed 8-bit number itself. Okay, so the simply question is that we have like 8-bit input. Okay, so we have like 32-bit output. But the thing is that whatever the 7 bit of the input is replicated 24 times and it's stored first, like from MSB side, first 24 bits is occupied by that 7 bit. After that, whatever the number in is, whatever the in number is there, so as it is, it's placed. Okay? So let's go and solve the question. So assign, so output name is out. Okay? Here we have to, we need to use concatenation. First, we have to use replication of 7 bit. Okay, so 24 times we have to replicate it. So 24, okay, 7 bit. Okay, so in then square bracket we have to put 7. Okay, so the bracket is in here. So for this one, we require one more curly bracket, then press comma. Then whatever the number of in is coming as it is. Okay, so in here, then put semicolon. Okay. So here 24 times 7 is replicated and store the first like MSB side of the out and then in as it is. Okay. Let's go and check it's working or not. Okay. Just I'm just pressing the submit button. It's compiling. Yeah, we get status success. Okay. Let's jump on our next question. So this is our last question. Okay, this is one more replication question. Okay, given five 1-bit signal A, B, C, D, E. Okay, compute all 25 pairwise 1-bit comparison in 25-bit output vector. Okay, we have to compare like, so there are like five numbers now. So each let's see. So A is comparing with all that bits once. Okay, so A is comparing with A is comparing with B, A is comparing with C, A is comparing with B, A is comparing with E. Okay, So 5 times this, so total five number like 5 bits are like 5 bit signals are there. So each is comparing with all five. So there are like 25 possibilities. And that 25 possibilities are like 25 bit signals are represented in a vector format. Okay. The output should be one if two bits being compared are equal. So when we get like when we are comparing two bits and we get like output equal to one or when and when only when we are performing XNOR operation. Okay, so we have to perform A XNOR with A, B, C, D, and E, then B XNOR with A, B, C, D, and E. Okay, in that way we have to put. So there are like multiple way. If we like directly doing with like in that way, we are required like so much time. Okay, so we are going with a simple method. Okay, so we are using concatenation sign for that. Okay, in single line we can write it using concatenation. So I'm just assign. So output is like 24-bit vector, name as out. Okay, so in out we have to perform the operation. Okay, so as here like 24-bit is stored by A. Okay, 23 A and B. Okay, so in that way, first we have to put A operation here, like A signal. So I'm just using concatenation operation here. So one more curly bracket we require. Okay, it's 5 times of A. So this is ending here. So this A is concatenated 5 times. One more thing we have here, we have to put XNOR sign for that, like XOR. Then where negative means XNOR operation. Okay, so we have to put one negation sign here. So I'm just putting here. Okay, it's better to put like outside. After that, we will fix it. It's required. Okay, so after that, comma. Here it's like so much confusing because we have to like put so much brackets here. So just copying it. This is for B. This is for C. This is for D. This is for E. Okay, so just changing the signals. C, then D, then E. Okay. So after that, what we have to do? We have to perform XOR operation with 5 times of A, B, C, D, and E. Okay. So let's go. This is XOR operation. Okay. 5 times of A, comma B, comma C, comma D, comma E. Okay. So that's it for the question. Let's put one semicolon and check it's working or not. Let's press the submit button. Okay, we get the status success. Okay, that's it for today's session. So all this code is like uploading. I'm just uploading on the GitHub and just put the link in that my website. Okay. So in tomorrow's video, we are solving these all questions: model, connecting ports by position, connecting ports by name, three modules. Okay. So this is like test bench, I guess, test bench and our TUT mapping questions. So we are solving all this question in next session. Okay. For that's it for today's video. Let's meet in next video.